Hello friends, today we are going to see integer reversal problem. Initially it may look like a very simple trivial problem, but actually there are lots of intricate details. And interviewers like this problem because this problem lets them not only analyze your problem solving skill, but also how you communicate, how you tackle constraints, and how you handle annoying situations. We will see that in detail while doing the problem walkthrough. Let's go through the problem statement now. Leetcode problem number 7, reverse integer. Given a 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside signed 32-bit integer range, 32-bit integer range is minus 2 power 31 to 2 power 31 minus 1. Then return 0. If the range is actually beyond the 32-bit limit, you have to return 0. And assume the environment does not allow you to store 64-bit integer, signed or unsigned. So the example 1 is given. If the x is given 1, 2, 3, you have to return 3, 2, 1. In example 2, if x is minus 1, 2, 3 and output is minus 3, 2, 1, it should be. And if the input is 1, 2, 0, output should be 2, 1, 21 because the leading 0 is not required. And constraints x is going to be between the 32-bit integer limit. And this comes under math. So there is no particular pattern here. It is all about how you handle math, how you do the calculations and everything. So to reverse an integer, let's take the example 1. X is equal to 1, 2, 3. We have to take this and write it in the output first. Then this should come and write it in the output. Then this should come here. And this is the reversed integer. So every time when you are iterating, we need to take the last digit and the second digit, and like this we have to go. So if we have a loop where we are going to split x into like this, like when x is there, so that loop is going to split the last integer and the rest of the x. So if we can able to split it like this, then we can construct something like this. To get the last digit of a number, so we can simply do modulo division. So 123 modulo division 10 is going to be 3. And next what we have to do is, okay, we got the last digit. Now the x we have to split the remaining one. We don't need the 3 anymore because we have split it. To take the split out of this one, we just need to do floor division. So x floor division 10, 123 floor division 10 is going to be just 12. We got this. So using modulo and floor division, we can able to split any integer into the last digit and rest of the digit. So we are going to use this inside a loop and we are going to construct the reverse number iteratively. Additionally, one more case we have to handle here. Suppose if the given integer is negative, so x equal to minus 1, 2, 3. In that case, we have to split the negative first and then the integer and reverse the integer 3, 2, 1. Then put the negative before the number. We know how to reverse. We are going to use modulo division and floor division to reverse an integer. So in case the given number is in negative, initially itself we are going to take the sign out and then we are going to reverse the given number. So after reversing the number, we are going to put the sign in front of the number and return to that. Let's go into the implementation. Let's create a new variable reverse. Initially set it to 0 and sign is going to be 1. If the given number is going to be positive, let's keep it as 1. If the number is negative, let's set sign to minus 1. So we can multiply that with the reversed number at the end. So if x less than 0, sign equal to minus 1. At the same time, we have to remove the sign from the given x, right? So to remove the negative, we have to multiply x with minus 1. Now we got the number in the x. Now we just need to construct a loop, and inside the loop we have to split the given x into the last digit and rest of the number and append that into the reverse. First take the last digit, add that into the rev, so we are multiplying rev with 10 because whatever is already there should be shifted one digit, right? So it should be shifted one position and the last digit should be added there. Suppose we have 1, 2, 3 and initially rev is going to be 0. So we split 1, 2, 3 into 1, 2 and 3 and we are going to add that into rev. So rev is having 0. We can simply add 3 into rev. But next time 12 is coming here, we are going to split 12 into 1 and 2. We cannot simply add 2 and 3. If we add 2 and 3, we will get only 5. But actually what we need to get is we need to get 32. So we need to shift 3 one position and then we have to put 2 here. To shift 3 one position, we need to multiply 3 with 10. So here we are going to do 3 into 10 plus 2. So rev into 10 plus the last digit. So this time it becomes 32 and next time 1 comes here. So we are going to split that into 0 and 1. So same way 32 is here into 10, 320 plus 1, it becomes 321. This is the reverse of given number 1, 2, 3. And this is what we are doing in the code. So we multiply rev by 10 before adding last digit with that one. And then we have to remove the last digit from the x. For that we are going to use floor division. So x equal to x, floor division 10. Now we got the reversed integer. Now we can simply return rev into sign. We have initially taken the sign out. Now we are adding that into the integer. If it is positive, we are simply going to multiply that with 1. If it is negative, sign is going to be minus 1. So we multiply rev with minus 1, you are going to get the minus number. But there is a constraint. If reversing x is actually causing the value go outside the 32-bit integer range, if the reversed number is falling outside of this particular range, we have to return 0. So we are going to add this constraint here before returning. If rev less than minus 2 power, so power is 2 stars in Python, 31, or rev greater than 2 power 31 minus 1, we are returning 0. So this code should work. Let's try with the test cases. All test cases are successful. Let's submit the solution. Okay, submission is accepted, but this is not the correct solution, because now once you write this code, your interviewer is going to highlight, assume the environment does not allow you to store 64-bit integer, signed or unsigned. It means your code should never use any integer that is beyond 32-bit length. So this row, if it can be less than this number and if it is more than this number, it means it is something beyond the given range. We need an integer which is more than 32 bits. So using a row which is a 64-bit integer is not allowed here. So that is the constraint here. Even though your programming language allows you to do this one, your interviewer is giving you an additional constraint that you should not use rev as a 64-bit integer. Some candidates will say why we have to take this constraint, because application languages allow this. So only in system programming we need all these things. But when you go to higher level language, we don't need to bother about this integer limit. Machines are faster, they have enough memory. So people will go into this kind of arguments, but that is simply time waste. And here the importance is not whether you can actually solve the problem or not, whether you can able to take the constraint and adapt to that or not. So this is not actually a very hard constraint, but it is kind of an annoying constraint. Even though the language allows, the interviewer is giving an artificial constraint, so usually candidates will kind of trip in this situation. But you have to keep yourself calm and think through, and you should let the rev should not overflow the given limit. It should not go beyond 32 bit. But to do that, you need to first understand the number system. You should know what is binary, how the numbers are stored as a binary. If you don't have that basic, you may not able to properly understand and you may not able to solve the coding problem in the given time. Let's first understand how the numbers are stored inside the machine as a binary. Keeping a reference of a 32-bit integer and then trying to learn the overflows and everything will be little bit harder, little bit tedious. Instead, let's try to keep only 4 bits and we'll try to understand the concepts with the 4 bit, and the same concept you can extrapolate to a 32-bit number also. So the word length is 4 bit. So it means you have only 4 bits to store any integer. And you know binary is allowing only 2 possible values to a given bit, which is 0 or 1. So you have 2 possibilities for a given bit and you have 4 bits. So how many different combinations you can store? So it is nothing but 2 power 4. which is nothing but 16 combinations. It is like a multiplex operation. So you are going to use these 16 different options to represent different numbers. It may not be very intuitive at first to make sense, but actually you have to understand about numbers a little bit. All the digits we write 0 to 9, these are just representation. They are not the actual numbers. The actual numbers, the 5, 6, but the digits are representation of those numbers. When you write two 5s next to each other, it is representing 55. 55 is the number. You can write that in with two 5s next to each other, or you can write that with different representation in octal or hexadecimal or in binary. The number doesn't change, but the symbols change. So when we are talking about binary, we are talking only about the symbols. So we have 0 or 1 as the symbol here, and we have 4 positions to keep the symbol. So how many different combinations we can store here is all 4 places can be 0 to all 4 places can be 1. In between we have like 14 more combinations. So in that case, single combination is a symbol. It's a combination of symbols, and this is going to represent one particular number. We are going to assign one particular number for one particular symbol representation. Usually what we will do is we will start from 0 and to the maximum. So what can be 16 symbols can be stored, as I said, but when you are including 0, you can go up to 15 because 15 numbers plus 0. So total 16. So when you are going to use all the bits for the value, so in the 4-bit location, you can able to store 0 to 15. So anything beyond that will be overflowing, and that cannot be stored here. So let's see what happens here. So let's convert 14 into binary. 14 in binary is nothing but 14 is 1, 1, 1, 0. And let's add 1 with that. So 1 in binary is 1, 2, 3, 4. Because we are going to use 4 digits for every number. So this is 1's representation. When you add 14 plus 1, which is 1, 1, 1, 0, 0, 0, 0, 1. So you add, it becomes, and this represents 15 in binary. Now let's see what happens when we add 1 with 15. So 15 is 1, 1, 1, 1, and you're going to add 1 with that. So you add these two. You cannot put 2 because 2 is not an accepted symbol in binary. You can only put 0 or 1. So when you add 1 plus 1, it becomes 10. So that becomes 0 and 1 goes to the carry. Add 1 to 1, 0 goes to the carry. 1 to 1, 0 goes to the carry. 1 to 1, 0, and this goes to the carry. But we don't have a place here to store. We don't have this place here. We have only 4 digits to store a number. So when an overflow happens, actually the upper bits are lost. So here 1 supposed to come, but because we don't have a place here, this 1 is lost, and we are storing only 4 digits. We are going to store only 4 zeros. So this is a bigger problem in every machine. When the machine is having only 4 bits of word length, you cannot store anything beyond 15. So when you store a number bigger than 15, the upper bits will be lost. So here 16 has 1 bit more than that, that is lost. So other numbers will have different other bits. So all the upper bits will be lost, only the remaining bit stays. So actually what happens here is, so when you add 15 plus 1, you are getting the output as all zeros. So all 0 in decimal is nothing but 0. So what we have seen is cycle through. So when the digits are only 4 digits are there, so you are going to store only 0 to 15. When you are going beyond 15, this will cycle. So this number will become 0. So 15 plus 1 will become 0. 15 plus 2 will become 1. 3 will become 2. 4 will become 3. So the cycle will keep on going. This you have to understand very clearly. So when the machine says, I cannot store more than 32 bits, but if you store any number more than 32 bit, it is not going to complain about that. It is simply going to lose the upper bits and cycle through the lowest number. It is going to come back to the first number and keep going, and you will not even know about that. You may think it is something trivial, but actually this has crashed on rocket in 1960s. Okay, now comes another problem. So we have seen how to store a number into the binary, but we didn't think about negative numbers, right? So we had 4 digits, so we stored 0 to 15 here. But what if we want to store minus 15 here? We don't have place here. All the digits we allocated for the numbers, we didn't have any digit for space. So in this case, we cannot store any negative numbers. That's why we call them as unsigned. So when you say unsigned numbers, there are no bit allocated for the symbol. All the bits are given for the numbers only. In that case, you cannot store any negative numbers in that binary representation. But when you go for signed, the first digit we are going to allow for sign. So this one is going to be sign bit. So when this becomes sign bit, you have only 3 bits for your number representation. So with 3 bits, we cannot store 0 to 15. We can maximum store 2 power 3, which is nothing but 8. So this goes to 0 to 7, and we have some negative numbers also allowed, right? So we can go up to -8. In negative we can go to 8, but in positive we can go up to 7. The reason is 0 is occupying the positive space. So the sign bit 0, all 0 will be 0, and when you go to negative numbers, this is actually representing -8. So if it is 0, all 0, and this is 0, if it is 1 and all 0, it is -8. So every time when you say your machine is only supporting n number of bits, how many numbers you can store there, you can easily calculate using -2 power n to 2 power n minus 1. That's what given in the constraint. It is a 32-bit integer machine. When the machine is 32-bit integer, you can store maximum of -2 power 31 to 2 power 31 minus 1. This should be the range. You should not store any number beyond this range in any variable in the program. If you do that, then you are actually violating the constraint and you are not allowed to solve the problem like that. Because in this machine it may be possible to solve. Actually, in a physical machine where the word length is limited, this may not be possible. That's why the constraint is given to you and you have to honor this one. So to see what will actually happen in negative numbers when it is overflowing, so when I say 4 bits for storing signed numbers, so the range is going to be -8 to +7. So it is going to be, -8 to 0 to +7. When you are going beyond this, it will actually cycle through -8. We should be careful about that. We cannot able to compare row with the max or min value, because row will be always between the given range. So in a 4-bit sign value, any value you add here, any number you are going to add, that number is going to fall only between -8 to 7. It is not going to beyond this. It is going to be always constrained inside this one. And if you compare whether the given number is less than -8 or greater than 7, it is going to be always false. So neither of the condition is going to be true, and every number you are going to put it into the 4-bit system is going to fall under this window. It cannot go beyond that, because as I told you, the upper bits will be simply ignored and the lower bits will always fall between these two numbers. This we have to account here. Let's keep the 4-bit numbers only. So we are going to have 4 digits only, and I have number 6. If I add number 5 with it, it is becoming 11, but I cannot store 11 here. So in a 4-bit machine, 11 will become -5. So -5 is going to always in the range of -8 to 7. So it is going to be true. I cannot compare whether 11 is less than -8 or greater than 7, because 11 is going to be stored as 5. So after doing the calculation, we cannot do the comparison. So what we should do is, so we need to determine whether this operation is going to cross the boundary or not. So how to do that? We need to have a max. Let's have min as -8 and max as 7. And to calculate whether this operation is going to cross this range, what we have to do is, if 6 greater than max -5, then we know that it will overflow. So what we have done is, instead of doing this operation, we are going to move this one to the right side. When it is going to the right side, it becomes negative. So After adding and doing the comparison, we are just comparing this number with the max minus the operation number we are going to do. We see this in the code. What operations we are doing here? We are actually doing one multiplication and then we are doing an addition. So when after doing the multiplication and addition, so the number may go beyond 32-bit limit. If it goes beyond 32-bit limit, it will loop through. So we have to do the reverse of this one with the max and do the comparison. Let's have the max here. So max is nothing but 2 power 31 minus 1. It is a 32-bit machine. So this is going to be our max. So this is 2 power 31 minus 1. So let's keep it like this. And here, before performing the operation, we have to check if rev greater than max divided by 10 minus last. We got it. So we are going to do multiplication and then addition. So to reverse that with the max, we are dividing max by 10 and removing last digit from that one, and that number, if it is going to be smaller than rev, if rev is bigger than that, it means it is going to overflow. If it is overflowing, we are going to return 0. We can directly return, and in that case this check may not be required. Let's try with example cases. All cases successful. Let's submit this code. It's a wrong answer. Let's add this to our test case. Seems like it is falling under some boundary case. Actually, what we do is max is allowed, right? This is inclusive. So it means 2 power 31 minus 1 is an allowed number. So we have to check the number before that. So we can add 1 plus 1 here. So it is a boundary and we have to allow this number also to be valid number. We should not return 0 when the row reaches this one after the operations. So if we try it with this additional boundary check, we'll get the test case successful. Let's submit the solution. Okay, our solution got accepted. Hope you liked this video and it was helpful to you. And this constraint handling situation you have to tackle seriously. Before start writing the code itself, you ask for every constraint and make sure you accounted all the constraints, because usually what will happen is interviewers will wait for you to write the full code, which may take 15 to 20 minutes. After you complete the solution, they will emphasize on the constraint. At that time, you may get little annoyed, you will try to argue back, which is not going to be helpful very much for you. So because they particularly mentioned the constraint and their requirement is going to be how you are handling all the constraints given. If you miss that, definitely there is going to be some shortcoming in the final feedback. So it is very important. If you like the video, please give a thumbs up and subscribe to the channel for more such videos. See you until next time. Bye.